Polymer is any of a class of natural or synthetic substances composed of very large molecules called macromolecules. As I've said a while ago, a polymers is composed of a bigger substances that are called macromolecules. And that macromolecules are simpler chemical units called monomers. Thermoplastic and thermoset. Thermoplastic and thermoset are used increasingly more frequently today in a wide range of electrical and electronics applications to perform many very different functions. In our modern world today, the polymer plays is a bigger role in our society. Thermoset and thermoplastic are the best example for that. The main reason for this trend is the amazing versatility of polymers, which enables the design and manufacture of vast range of products to meet very different application requirements at acceptable cost. The abilities to prepare blends of polymers to incorporate many types of performance enhancing additives and to prepare polymers matrix composites by incorporating reinforcing agents such as fibers, plating, fillers, and particulate fillers. All enhance the versatility of polymers or beyond the versatility provided by individual polymers on their own. The properties will therefore be discussed under the following four subheadings. Electrically insulating polymers. Intrinsically conducting polymers. Adhesive coatings, coating, compounds, and sealants. All polymers. Thermosets are currently widely used in an array of electrical parts and applications for strong electric property benefits such as low arc and trip, and high dielectric strength and heat resistance. Additionally, thermosets can be UL rated at VO or by VA for flammability resistance, offering a high performance material at much lower material cost per pound versus similarly performing thermoplastics such as PA66, PC, or PPS. Some other examples for thermoset plastic polymers include silicons, vulcanized rubber, epoxies, polyesters, and phenolics. Common thermoset materials include natural rubber, SBR, neoprene, and hypalon. Thermoset materials don't melt, so they are often used in high temperature applications or in circuits at risk of overload. This means that thermosets will not melt even when exposed to extremely high temperature. Common examples of thermoset plastics and polymers include epoxy, silicone, polyurethane, and phenolic. That is the whole meaning of polymers in the electrical application.
Sana all.
At this moment, let us proceed with the application of polymers in the electrical application.
Oh my god! Wow!
Electrical conductivity. The low electrical conductivity is the first requirement for any material for us to have a strong insulation in the electrical purposes. That is why electrical applications of the polymer is very important so that to give insulation to the current that is being delivered by a certain circuit of insulation. The low electrical conductivity is the basic requirement for a polymer to be imposed, right, by the certain electrical material, so that the insulation will be merely obsided by the electrical applications of a polymer. Mechanical and thermomechanical properties. The following properties of the polymers are very important for housings, covers, enclosures, and insulation. We have this flexible insulation. Flexible insulation means that the polymers are must be flexible enough so that in the area of electrical application, it must have a low elastic modulus. And the second is rigid insulation. From the word rigid, right? So rigid, there are insulation that are rigid, that is very hard in nature. It has a dimensional stability and impact resistance. We have this durability. So when we say durability, the polymers must be long lasting, because, like for example, in the electrical applications, we are using polyvinyl chloride. So the polyvinyl chloride or PVC, they must be long lasting, so that the maintenance of the owner of the certain building will not hesitate to do it annually or maybe
Sana all.
daily. That is why a polymer must be durable and is compatible in a certain area. We also have this thermal conductivity. Thermal conductivity in the polymers, they are very important. Why? Because, as I've said a while ago, in the electrical applications, um, those materials that are being used must be compatible in thermal or heat or hot places. That is really important to provide thermal insulation. Another one is fire resistance. Fire resistance. In the electrical application, fire resistance of the materials that are being used in the electrical area, those materials that are polymers, they must be fire resistant materials. Why? Because it is very important to protect, like for example, we have these wires, right? Wires or conductors. They must be protected because their coatings are just thin to be burned immediately by a fire. That is why we should put or protect it by a fire resistant material in the electrical application. And the last one is anti-static performance. When we say anti-static performance, from the word anti, meaning against, alright? And the word static, what do you mean by static? So, from the word static, so it should be an important part of the electrical application. What? So that the materials that is being installed by the electricians will be protected and will be perpetuated
Sana all.
in many years, or in a long lasting, right? In a long lasting moment. That is the word of being applying the word polymer in the area of electrical application?
Spicy meat. Yeah, boy.
Polymers are increasingly being used a wide variety of applications in electronics and photonics, most of which use polymers in their traditional role as engineering materials.
Sana all.
Circuit boards, molded products, wire and cable, insulation, encapsulants, and adhesives. Adhesives, coatings, patting compounds, and sealants. Adhesives are used extensively in electrical and electronics equipment to bond components to each other. Different adhesive types and how to use them. Epoxy adhesives. Epoxies are type of structural adhesive. Polyurethane adhesives. Polyurethanes are polymer-based adhesives used for construction, requiring high-strength bonding and permanent elasticity.
Spicy meat. Yeah, boy.
Example of adhesives: base, liquid, film, fillet, and hot melt. What is a adhesive used for? Adhesive, any substance that capable of holding material together in a functional manner by surface attachment that resists separation. Adhesive, as a general form, includes cement, mucilage, glue, and paste, terms that are often used interchangeably for any organic material that form an adhesive band. Five common types of adhesives. Epoxy. Epoxies are known to be long-lasting, versatile, and heat-resistant. Cyanoacrylate, aka superglue, hot glue, or the glue used in the glue guns, is also considered craft glue. Wood glue or white glue is a type of PVA craft glue. As moisture, dust, chemicals, temperature extremes, UV radiation, and high energy radiation. Coating means a protective, decorative, or functional film applied in a thin layer to a surface. Such material include, but are not limited to paints, top coats, varnishes, sealers, stains, wash coats, base coats, enamels, inks, and temporary protective coatings. Coatings are specified as organic or inorganic according to the nature of your binder. Organic coatings are those that have an organic binder. Inorganic coatings are those that have an inorganic binder, such as silicate. Coatings are varied, but primarily fall into three categories: architectural, industrial, and special purpose. What is meant by patting compound? A protective insulating and sealing plastic used to embed electric coils in a container. Patting provides excellent abrasion resistance as well as protection against that chemicals, impacts, and other patting compound. Materials include epoxy, polyurethane, and silicone compounds to protect electrical and electronics equipment from damage. What is meant by patting compound? A protective insulating and sealing plastic used to embed electric coils in a container. Patting provides excellent abrasion resistance as well as protection against that chemicals, impacts, and other patting compound. Materials include epoxy, polyurethane, and silicone compounds
Oh my god! Wow!
to protect against environmental influences, improve mechanical strength, and high electrical insulation. Sealants. Sealants are also used to protect electrical and electronics equipment from damage. Sealants are used both in industrial settings and do-it-yourself application. Sealant is a substance used to block the passage of fluids through openings in materials
Electrical properties of different polymeric materials and their applications. The influence of electric field. Aromatic dielectric materials. First, polymers. Aromatic polymers have excellent dielectric properties and are very useful materials at high temperature and voltage. These materials are chosen as interlayer dielectric in thin film microelectronics packaging because it is based on a matured technology and satisfy the requisite properties to maintain the mechanical stress associated with microelectronic fabrication processes. The second one is polynitriles, namely acrylonitrile, butadiene, and carboxylic acid. The properties of the polymer depend on the composition and attachment of monomers. The monomers are contributing individual ability to control the overall properties of the polymer. The third one is silicon-containing dielectric materials. Silicon-containing polymers are made up of the siloxane unit, means alternating chain of silicon and oxygen atoms. Combined with carbon and hydrogen, the materials have excellent heat-resistant properties and they are used as insulators, lubricants, adhesives, and sealants in electrical, thermal, and pharmaceutical industries. The fourth one is epoxy resins. Flexible thermosettings resins are known as polyodides and are formed by copolymerization of an epoxide with another compound having two hydroxyl groups. Epoxy resins was the first discovered by Pierre Castans, a Swiss chemist in my year 1938. The fifth one is aging in polymer insulation systems. The aging process present in the insulation system of an electric machine or equipment can be defined as the irreversible changes of their intrinsic properties due to action by one or several degradation mechanism or factors. These mechanisms are imposed by the operation, environment, or text that influence the performance of the insulation material. The sixth one, electrical stress. The presence of non-uniform helps in polymeric insulation is a necessary condition for dielectric aging under normal voltage and over voltage conditions. Thermal stress. Thermal stress can be considered another important stress factor in polymer insulation systems. Since the increased temperature and heat cycles accelerate most of their degradation processes such as oxidation, hydrolysis, chemical attack, and mechanical trip. Environmental stress. Environmental stress can be identified as one of the main reasons of the failure in polymeric insulations. Among the main factors of environmental stress, the authors would like to highlight sunlight, gamma ray and X-ray radiation, salt and dust and contamination, acid rainfall, and even pressure. And the last one, mechanical stress. For most of the electrical environment equipment, mainly electric and machine, the mechanical stress can appear in the form of compression, tension, banding, vibration, and impact.
Sana all.
adhesive types and how to use them. Epoxy adhesives. Epoxies are type of structural adhesive.
The nitrile polymer is composed of three monomers, namely acrylonitrile, betadine,
Sana all.